Hi, in this video I'm going to show you how to test a transistor using a digital multimeter. So before we do that, I'm going to show you how to test a diode. So this is a typical construction of a diode, which basically consists of two layers of semiconductor being sandwiched together, which is a p-type and n-type. So when we apply a positive voltage here and a negative voltage here, a current will start flowing. That's what we call a forward bias. And if we connect the other way around, positive here and a negative voltage here, the current will not flow. This is called reverse bias. So in forward bias, which we will using during testing, when it's in forward bias, let's say we supply a 3 volts, when current starts flowing, there will be a diode drop or voltage drop, or another thing like it's called a forward bias voltage. And to measure that is actually quite easy. So you just take your multimeter and place the probe on the diode pin, and then you will get the reading for the voltage drop across the diode. In this case, like silicon diode, you will get pretty much close to 0.7 volts. Now let's move to the transistors. So transistors basically consist of 3 layers of semiconductors. They are sandwiched together, and it looks like a diode being placed back to back. So we can do the same thing the way we test a diode. So to identify which one's PNP or NPN, we simply place a probe. We need to test which pin that's actually conducting. So let's, for example, like we place a positive probe here and a negative probe here, or ground probe, and then once we place it there, we will get a reading, which means the current is flowing. And also, when using a digital multimeter, make sure it's in diode setting. So on the probe, there's actually a voltage being supplied as well. So when you place your probe on the positive or p-type and n-type, which means it's now in forward bias, and you will get the voltage drop on the meter based on across it, which is the voltage drop across the PN junction here. So to find another pin like this one, if we place another probe here, we also get a voltage reading on the digital multimeter, which means we know that these 2 pins are p-type and the center one is n-type. Then we also know that this black probe here, which is doesn't move, only this probe is moving. We know that this pin is base pin, and the same thing we do as the NPN. We simply probe in which one we have a current flow. If we have a current flow, let's say we put in this way, so we know there's a voltage reading, then we know this one is p-type, this pin is n-type. So when we move the other way around, we also get a reading, which means this one is NPN, since the only negative probe is moving and the only one pin stays on positive probe, which means it's a p-type. So we know that it's NPN. So how do we know which one is emitter and collectors? It's actually quite easy, and when we measure it, let's say this pin right here, we will get a forward voltage reading, or a voltage drop actually. It's a voltage drop reading about 0.666, and on this pin we will get somewhere 0.669. The value is actually not really large, but there's significant changes in there. So now we know that the highest voltage drop across it is will be called the emitter, and this one is the collector pin, and this one of course the base pin. The reason that this PN junction on the base emitter, because the p-type on the emitter is heavily doped with impurities, that's why it has greater voltage drop compared to a collector base junctions. Okay, So that's how you identify which pin is emitter and collector. Same thing as the NPN type. So let's try measure one. Let's test. So I'm going to use normal transistors here. I'm going to tell which part it is. Probably see the label there. So set your multimeter to a diode setting, and then I should place it right here. There you go. So we have 3 pins. Let me zoom in a bit. Maybe too close. Okay. So let's test one. So when I apply the center pin and with the ground probe and a positive probe, we got a forward bias voltage. And when I move this probe around, nothing happened. So which means that's not the right pin. So we move this probe around, we also get a reading. So we know we only move one probe here. So which means this probe is P-type. N-type. So this one is P-type because it's a positive probe. So this is P and P. So how do we know which one base collector and emitter? Well, this probe here, the ground probe, is basically the base. And if we take a look at the multimeter, this pin is 708 and this pin is 712. So we know that this one is the emitter pin, this one is the collector pin, and that's how you identify a transistor pins. So let's try other transistors. I'll put this one on the breadboard. Hang on. Okay, I have another transistor here. So let's try probing it. So let's try the same way. Do we get the same reading? Nope. Let's probe this one. Nope. So let's try the other way around. There you go. We got a forward bias voltage. Now let's move this probe around on this side. We also get a reading. So now we know that this pin is P-type and this one is N-type on this side. So we know that it is an NPN transistor since there's a negative probe here. So which one is base collector emitter? This one is the base because it's the only probe that doesn't move. So this one is 661. This one is this one is in 660. 661. 660. So we know that this one is the emitter pin, this one is the collector pin, because the forward voltage drop across this pin is higher than this one. And that's how you identify transistors and which pin is base collector and emitter. And that's all for today, and don't forget to subscribe for more future videos.